Hi guys, Mr. Max here. Today we'll be talking about vector tools where we're going to touch on vectors line. So we're going to talk about everything related to lines. So it can be from point to lines, can be from line to lines. Of course, the other part which we will touch about lines and place, we will be touching that more on vector 3. So let's talk about the first thing that we're going to talk on, which is vector equation of a line. Vector equation of line is generally categorized as R equal to A plus lambda D. And we have to state that lambda actually represents any real numbers. So how does this vector equation works? So let's say we have a line here that we're going to talk about L. L have a point that lies on the line, which we call A. And R represent any point that lies on the line. So R can be here, R can be here, R can be here, R can be here as well. So basically, R represent any point that lies on the line. So assuming we're going to take R that lies on there first. So we talk about origin here. Okay, this is vector A. And this is R. Like I say, R represents any point that lies on the line. Also, line is also parallel to a direction vector called D. So in other words, to form a vector equation of a line, L, R represents any point that lies on the line equal to A, which represents a point that lies on the line, plus lambda D, where lambda is real number. This can be seen from what we learned in vector 1, where we talk about vector addition. So R is equal to A plus certain value of lambda, which get me back to the same point. So let's come back to these examples over here. We're going to talk about these three examples. So first example, vector equation of a line that passes through 1, 3, minus 7 and parallel to the vector 1, 4, 9. So what we're going to do is we're going to create a line equation. So part 1, line R is equal to a point that lies on the line. In this case, we are talking about 1, 3, minus 7. And of course, the direction that is the line is parallel to. In this case, the direction will be lambda, 1, 4, and 9, where lambda is real number. Now, part 2, a line passes through a coordinate of 0, 2, 8, and 6, 10, minus 2. So if we want to quickly draw the line is going to look like this right here. And there will be two coordinates. Let's say A, which is 0, 2, 8, and B, which is say 6, 10, and minus 2. So to get the direction of this line, we will need to find a direction AB. So assuming what we're going to do is, if we recall in vector 1, AB is equal to OB minus OA. So what we're going to do is, we're going to take 6, 10, minus 2, minus away 0, 2, and 8. Essentially, this will give me 4, 8, and minus 10. Now, take note, because this is the direction, 4, 8, and minus 10, I can simplify further to take out 2 to give me 2, 4, and minus 5. Take note, 4, 8, minus 10, and 2, 4, minus 5 are in the same direction. So in other words, for line equation, we can actually simplify our direction vector. So in this case, my line equation over here will be L, R equal to A plus lambda D. A represents a point that lies on the line, D stands for a direction. So I can use any of the point, can be used 0, 2, 8, or can use 6, 10, or minus 2. Both answers is acceptable. So let's say we use 0, 2, 8, a point that lies on the line, plus, since I already used lambda in part 1, I'm going to change my variable. So I'm going to use mu over here, and mu 2, 4, minus 5. Do remember the right mu is element of real number. Now last one, part 3, passes through a point 2, 4, 2 and is perpendicular to both the vector 1, 1, 1 and 2, 1, minus 3. So I have a point which is 2, 4, 2. So great. How about the direction of the line? The question did specifically say that the line is actually perpendicular to both the vector 1, 1, 1 and 2, 1, minus 3. So what we learned in vector 1 is that to find a direction or to find a vector that's perpendicular to two vectors, I will have to cross them. So what I'm going to do is, I'm going to take 1, 1, 1, cross with 2, 1, minus 3. Okay, do a quick math. You should be able to get, cover the top, you get minus 3, minus 1. Then the second row will be minus 3, minus 2. And the last row will be 1, minus 2. Okay, further simplify, I'll get minus 4, 5, and minus 1. So this will be the direction of the line. So my line equation will simply be L, R equal to a point that lies on line which is 2, 4, 2. Okay, since I already used lambda and mu, I can use alpha as well. Alpha minus 4, 5, or minus 1, where alpha is real number. Take note, if you really want to simplify further, you can also write our line equation to be this. R equals to 242 plus alpha 4 minus 5, 1. Both answer is acceptable. Because the reason why I want to use the blue portion is because I'm going to reduce the amount of negative sign, which will help me further to solve questions easily when you're going to go on to application with line.